On this question, we have a system of nonlinear equations. We want to sketch the graph of each equation and then determine the number of real solutions to the system. We don't want to solve the system. We're coming up with the sketch and then determining how many real solutions there are to this system. The first equation in the system is x squared minus y equals -4. And the second equation is 3x minus y equals -6. So I can tell that the first equation is going to be a parabola or a quadratic because of the squared on the x, and the second equation is a linear equation. I'm going to start with that first equation, x squared minus y equals -4. And I'm going to rewrite this as y equals, so it's easier for me to graph. I'll subtract x squared. That gives me negative y equals -x squared minus 4. And then I can divide each term by -1 to get y equals x squared plus 4. So my first equation will have a graph of x squared shifted up by 4. So I'm going to sketch that picture over here. We have a picture that looks like this. And the second equation, 3x minus y equals -6. This is a linear equation. And I can graph this using the intercepts. I have an x-intercept by letting y equal 0. That's 3x minus 0 equals -6. 3x equals -6, and I'll divide by 3. X equals -2, so I have an x-intercept at -2, 0. And for the y-intercept, I would let x equal 0. That's 3 times 0 minus y equals -6. Negative y equals -6, and I'll divide by -1. That's y equals 6. So I have a y-intercept of 0, 6. I'll plot my x-intercept at -2, 0. And my y-intercept at 6. I'm going to connect those 2 points with a straight line. If I extend this parabola a little bit further, I can answer the question about the number of real solutions in this system. The solutions to a system of equations will be ordered pairs that make each equation true. So we're looking for intersection points, because those intersection points are points that will be on both lines and will satisfy or make both of those equations true. So we know that this equation or this system will have 2 solutions because we see 2 intersection points. I want to take a look at the graphing tool that we have in MyMathLab for this question. You can see here, this is where we sketch the graphs, and you do have a quadratic tool. If you'll notice here, it says 3-point quadratic tool, which means that I need to click 3 places, 3 points on the line to be able to graph this equation. So it's not enough to just know what the equation is and what the basic shape is. We need to have 3 points on this curve in order to plot it. So I can make a quick chart here of x's and y's, and I'll use -1, 0, and 1. And substitute that into our equation to get the y coordinates. I have -1 squared plus 4 would be 1 plus 4 is 5. 0 squared plus 4 is 4. and 1 squared plus 4 is 5. So this gives me 3 ordered pairs that I'll plot in order to draw that quadratic or parabola graph. I already have 2 points to draw the line, so I'll be able to draw this curve now. So selected that quadratic tool, 3-point quadratic tool, and I'm going to click on 0, 4, 1, 5, and -1, 5. Those are the 3 points that I found, and then it drew the rest of the pattern of the quadratic. And then I want to draw the straight line. Let me remind myself about what those ordered pairs are. -2, 0, and 0, 6. -2, 0, and 0, 6. And we have our 2 equations for the system. And then we want to know how many solutions are there, and you can see from this picture, just like the one we drew by hand, that there are 2 intersection points, and so that will mean there are 2 solutions. Okay. Thank you for checking out my videos. Have a great day.